So in the previous video we have discussed about the concept of electric field, and as I said you that electric field is the very most, or you can say the foremost topic, because after understanding the concept of electric field, then only you can switch on to electric dipole, and electric field due to various different types of shapes will be calculating. So electric field was a very important topic. You can see in the previous video I have explained about electric field, and let us discuss about electric dipole today. Electric dipole is very interesting topic. In this topic we'll discuss what is electric dipole, what is the unit of electric dipole, right, and how to calculate electric field because of dipole, right, and also we'll solve the sums based on electric dipole, right. Okay, di means two, electric means charge, right. So it is basically a system of two charges equal and opposite, right, separated by some finite distance 2a. This is known as electric dipole. Electric dipole is system of two equal and opposite charges separated by finite distance, right. First of all, two equal and opposite charges means if this is of 5 coulomb, then this will be of minus 5 coulomb. That means magnitude wise both the charges will be same, right. Polarity wise they will be of different kind, right, opposite kind. So if this is plus, this will be minus 5, plus 5, minus 5. If this will be 10, this will be minus 10, right. This is 15, will be minus 15. Okay, so separated by some finite distance, the arrangement is known as a dipole. This is known as electric dipole, right. Okay, so the distance between them is written as 2a. Now this will create a kind of confusion that why the distance is given as 2a. It is actually like we can mark the axis. No, let us take this as origin. This will be the y-axis and this will be the x-axis, right? So this is say the distance a from the origin. This will be minus a from the origin, right? So the total distance will be 2a, right? But it is not always necessary that you will remember this as 2a. Sometimes they will say you that electric dipole can be also defined as a system of two and equal and opposite charges separated by any distance d. Clear? Okay. So now electric dipole means a system of two equal and opposite charges separated by some finite distance. This is known as an electric dipole, right? Okay. Now to determine the strength of electric dipole, we have defined a vector quantity, and it is known as dipole moment. Dipole moment. Dipole moment is denoted by P. It is a vector quantity, right? It is magnitude wise any one of the charge, because as I said you before that magnitude wise both the charges will be always same. If this is of 5 coulomb, this will be of minus 5, means magnitude wise both the charges will be equal. If this is 10, this will be 10, this will be 15, this will be 15, right? So dipole moment is a vector quantity which is denoted by P, which is magnitude wise any one of the charge into the distance between them. What does dipole moment signify? It determines the strength of electric dipole, right? Strength of electric dipole is determined with the help of a vector quantity, say dipole moment. Clear? See, in many reference book, what is actually dipole moment has not been mentioned. So you can note it down. It determines the strength of electric dipole, right? And dipole moment is a vector quantity. It is magnitude wise any one of the charge into the distance between them. As it is a vector quantity, so we need to assign the direction, and the direction of dipole moment will always be from negative to positive. It will be from negative to positive. As you can see in the diagram, there is a dipole, and this will be the direction of dipole moment. Clear? right? Okay, now let us discuss unit of this dipole moment, right? So dipole moment is defined as charge into 2a, so its SI unit is coulomb meter, because unit of charge is coulomb and unit of distance is meter, or you can also say it as d by, this is another unit, SI unit of dipole moment, and 1 d by will be 3.3 into 10 raised to minus 30. This is only for your information, coulomb meter. Clear? Right? So this is about electric dipole. Okay. Now, so this was all the introduction of electric dipole, its unit, what is the use of dipole moment, what is the direction of dipole moment, right? See, if it is being asked what is the net charge on electric dipole, as charge is a scalar quantity, right? Charge is a scalar quantity, dipole is having plus q charge minus q charge, so net charge will be q minus q, that is 0. Right, so net charge on an electric dipole is always 0 because charge is a scalar quantity. You need not to assign any kind of direction to it, right? One more thing, suppose I am taking a point P over here, right? The distance is say 2a and the point P is at a distance of x from positive charge, right? This is a point charge. As discussed in the previous video, point charge will produce an electric field kq by r square, right? And the direction of electric field will be radially away for positive charge, and for negative charge it will be radially inward, right? So what is the electric field produced by positive charge at point P? K q by x square, right? What is the electric field produced by negative charge at point P? K q by x plus 2a the whole square, right? So electric field of positive charge will be more than that of negative charge, right? And the direction of electric field because of positive charge will be outward, negative charge will be towards, but since this is having more value, so resultant electric field will be in this direction, right? It means even though net charge on a dipole is 0, electric field along the axis of the dipole is not 0. Right, so it is not always compulsory that if net charge is 0, then electric field should also be 0. This is an example, right? In dipole, your net charge is 0, but electric field is not 0, right? Okay, now let us solve one question based on electric dipole, and then we'll find electric field because of dipole, right? Okay, so let us solve one question based on electric dipole, right? The arrangement is shown to you. There are two dipoles, right, and the angle between two dipoles is 60 degree. You have to calculate the magnitude of electric dipole moment. So first of all, you have to make this minus 2q charge as minus q charge plus q charge, one dipole. Another minus q charge plus q charge, two dipole, because we have discussed that dipole is simply system of two equal and opposite charges, right? Okay, so then you don't have to think this way, minus 2q and plus q, this is not a dipole, right? Minus 2q is being divided into two parts, minus q plus q, minus q plus q. So there are two dipoles and dipole moment is from minus to plus. This will be in this direction, another dipole moment in this direction, as dipole moment is a vector quantity, right? So there are two vectors, p, another vector p, right, and this is the angle between them 60 degree. You have to find the resultant dipole moment. This will be the resultant dipole moment according to law of parallelogram, right? And how to calculate the resultant dipole moment? The resultant dipole moment will be calculated by the formula you have studied in vectors, a square plus b square plus 2ab cos theta, right? So here we need to write as p square plus 2 into p square cos 60. But what is cos 60? 1 by 2. So it is finally root 3 p square plus p square plus p square, root 3 times p, right? So that is root 3, p means charge multiplied by the length or the distance. So root 3 QL is your answer. देख लो. Okay, and if in a given dipole, if it is mentioned that the charge on the dipole is very large and the distance between two charges is very less, then such a kind of dipole is known as point dipole, ideal dipole, or short dipole. A perfect definition is if Q tends to infinite and 2A tends to 0, right? If charge on the dipole is increased too much and if the distance between two charges decreased so much, then this kind of dipole is known as short dipole, point dipole, or ideal dipole. These are all the different kinds of names given to the dipole. There also exists a physical dipole, but that is not included in your syllabus. The more discussion about physical dipole will not have. But if Q tends to infinite and 2A tends to 0, then the dipole is termed as short dipole, point dipole, or ideal dipole.